Hi everyone, welcome back. Today we are solving minimum number of flips to make the binary string alternating. So we will be given a binary string S consisting of ones and zeros, and we can perform two operations on this string. The first type is to remove the character at the front and put it at the back, and the second type is to pick any character and flip it either from 0 to 1 or from 1 to 0. And we want to return the minimum number of type 2 operations to make S alternating. So this implies that this will not count towards the number of operations, only type 2 will count. So we can actually perform this as many times as we want without affecting the minimum number of operation. And the string is called alternating if no two adjacent characters are equal, meaning no two consecutive zeros or no two consecutive ones. So like this is not alternating because there's two consecutive zeros. So if we look at this example, we can flip this to 0 and then flip this to 1, and that would take two operations. This is already alternating, so we can return 0, and for this one we can flip this to a 0 and it will be alternating, so it only took one operation, so we return 1. So now that we have seen some examples, let's get to how we can solve this problem. So one thing that we should know to solve this problem is that there's only two options for it to be alternating. It can be in a sequence of 1 0 1 0 1 0 and so on, or 0 1 0 1 0 1 and so on. And what we want is the minimum different number from the original string to these two strings. So let's say our number is like 1 0 1 0 0 1. Then we will look at the minimum different ones. So same, different, same. So it will only take one operation because there's one different number from the original string using this string. Obviously this one would take more, so we would convert it to this one for this example. So now to fully solve this problem, we can perform all type 1 operations, and after each type 1 operation we will check the difference between the string to these two sequences, and finally we will return the minimum difference that is found after we have performed all type 1 operation and finding the difference each time. But if we solve it this way, it will take O of n squared because we will perform type 1 operation n times, because if we were to have a string like this, we bring this to the back, and then now we take this and then do this, it will take n time to do the type 1 operation to test all combinations, and for each one we will look at the number of differences from this to this, so that's why it will take O of n squared if we solve it this way. So there's actually a more efficient way to solve this problem, and we can go over that way right now. So one thing we realize is that when we are flipping, we can actually just double the length of the strings we're comparing to and the original string, and we can kind of look at this as windows. So the first time we will compare these parts, and as we perform a type 1 operation, it will now look like this, and we realize that this entire section has remained the same, so we don't need to recalculate each time, and rather we can use a sliding window to maintain the total difference for these parts. And obviously as we shift this left side of the window, we need to also update from here and also update from here. Now honestly, I think for this problem it's better to just look at the example walkthrough, but in case if anyone prefers to see it in words, this will be how it looks like. So we will first initialize start 0 and start 1. The start 0 string will look something like this, the start 1 string will look something like this, depending on how long we need them to be, and then we will set S, the input string, to S plus S, and now we will calculate the differences with the sliding window. So set result to infinity, difference 0 for start 0, difference 1 for the difference between the string and start 1, and we'll set the left pointer to 0, and now we'll iterate from index 0 to length of S, and this will be the right pointer. So if we come across a different number that is found, update difference 0 or different 1, which just means to increase by 1 if needed. And now if the length of the window is greater than the length of the string, then we will have to shift the left window and decrease difference of 0 or difference of 1 by 1 if needed, meaning if it was originally a different number, as I was saying here, as we shift the left window we need to update accordingly. And now if window is equal to length, then we can update the result, so it will be the smallest between current result, difference 0 and different 1, and finally we'll return a minimum difference, which will be result. So let's go over this example real quick. So first we need to calculate the difference with the first string, shift the right pointer again. It's different from start 1, so update difference 1, update difference 0 because this is different to this, and update this again because this is different to this. And now, since we have a length that is the size of the string, we can update the result, which would be 1 is the smallest. And now we can perform type 1 operation, bring this to the back, but these will remain the same. Bring this to the back, these will remain the same because as we can see, 3 differences in start 0 and 1 difference in start 1. Bring this to the back again, it'll stay the same, and bring this to the back again, and of course it'll stay the same. So now that we have come to the end, we can return 1 as our result. And the time complexity would be O of n, where n is a number of characters in the string because that's the number we will iterate through. And the space complexity would be O of 1 because the size of these variables will not depend on the size of the string. So now let's get to the coding part. So first we will initialize length to the length of the string, because we're going to edit the string to s plus s, and we can initialize start 0 and start 1 to empty string. And how we will build these strings is we can look from I to range length of s. Now start 0 will add by 1 if I divided by 2 has a remainder of 1, otherwise we add 0, and we'll do the opposite for start 1. Now we will initialize result to float of infinity. Difference of 0, difference of 1, and the left pointer will all be 0. And now we'll iterate through the right pointer. So for right in range length of s, if s of right does not equal to start 0 of right, then we will edit the difference. And we will do the same for start 1. And now if the window size is larger than the length of the input string, then we will have to shift the left pointer. So if right minus left plus 1 is greater than length, and we need to update the left side if needed. So if s of left does not equal to start of 0 of left, decrease difference by 1, and the same for start 1. Need to decrease the difference by 1 because now there's 1 less difference, and now we can shift the left pointer. And now if the size of the window is equal to the length of the input string, then we can update result, which would be the smallest of result, difference 0 and difference 1. And finally we can return result in the very end. Let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.